Good morning, good afternoon, and good evening, everyone. My name is Michele Macchioni. I'm the Vice President for Data Infrastructure Processing and Automation in the HyperWorks team. And today I'll be starting about post-processing. As you can see, I've been also rebranding the name of this with the new HyperMesh post-processing. As you know, we are undergoing a full rebranding of all the simulation solutions under the HyperMesh umbrella. So I think it makes sense to have this webinar called really the new HyperMesh post-processing. And the agenda for today's webinar is going to be divided in 4 parts. I will be taking care of showing you the update on the HyperMesh post side and on the new free body workflow still in HyperMesh. And then I will be handing over to Varun, who will take over the discussions about the enhancement on HyperView and HyperGraph. I also want to mention that 2023 has been heavily focused on the content of moving the HyperMesh interface from the dual to the single process. And this is also what our development team has been namely focused throughout the complete release cycle. That being said, we have been trying to do our best to achieve extra content and also to achieve, polishing the performance and resolving other issues that have been reported by our customers. All right, moving on. On the HyperMesh post side, I'm going to focus just on 3 major, let's say, enhancements that we made, and I think they are very useful for our workflows. And I'm going to show you the, let's say, the support of the relative path when it comes to the results pointer. Then a big enhancement on the memory management, first of all on the results query, and then the development of the custom category legend. On the relative path, for those that I hope have been using heavily HyperMesh post in these previous releases, we know that when we save the database, the path was saved as an absolute 1 with respect to the file locations of the results being them either H3D, H5, ODB, OP2, and whatnot. Right now, with the 2023, we're able to store the relative path with respect to the locations of the saved HyperMesh database, while the path would be kept absolute in the case the driver changes. So you may have a file in the C drive and your results are hosted on the D drive or whatever. In that case, the path will be kept absolute. So how does it look like? You may have your HyperMesh sessions with the results resources pointed. When you import them, you can still see the path, let's say, absolute to the location where your session is. Then when you save the HyperMesh database into any, let's say, drive, at that point, the location is automatically updated to be local to where the HyperMesh database is stored. What does it mean? It might sound pretty small, but it's going to be very effective specifically for sharing the database and the results to other colleagues, to development, to customers, get them from the customers without losing any information. So it's going to boost, obviously, the usability of the tool. Next one, which I think has been really focusing the development from all the sides, so not just from the HyperMesh posting, but also from the, let's say, post backend, namely the R data team, which I'm explicitly thankful for that. Great work has been done on improving the memory bookkeeping while running the results query extraction. And this has been also improve the query executions and execution time on a large data set. The picture that I'm showing, I believe, talks itself, but I want to mention once again a test case setup that we had. We have a big customer set of results. Actually, there were 2 big files of 30 GB each, and we were performing the query around 375 load cases on 47,000 elements to create, as you know, the big CSV file, screening in this case stresses in the elemental system for shells. In the 2022.3 release, the amount of memory which was requested by the process was piling up almost to 30 GB. and in other cases even more, making actually the application choking or crashing because of memory unavailability. And then the process, because of that, was taking, at least in my machine, around 23 minutes from running the complete process. In 2023, thanks to this new mechanism, we were able, first of all, to reduce the time, as you can clearly see, from 23 to around 17 minutes of the complete executions. But the most appealing KPI that you can measure yourself is the reductions from almost 30 GB to barely 7.5 gigabyte of memory consumptions. This obviously help the further parallelizations of further queries and keep the control of the complete responsiveness of the application. So this is, in my point of view, a great announcement. I want to mention that it's just the beginning. We are actually working more and more towards more flexibility of handling the memory peak and the way the memory is going to be used. As you know, memory and speed are kind of fighting against each other. So the more memory we use, this faster is going to be the process, and so on and so forth. But we want to reach a suitable compromise for all the possible use cases. Another point that I want to stress again, as I mentioned, this is not on the application level. This is on the common post backend that we are very heavily pushing to be the only one among all the applications that are dealing with post-processing. Internally, we call it our data. Obviously, this is going to be beneficial not just for the HyperMesh post, in this case, obviously for 2023, since we are exposing this, but the more we are moving towards this type of modularizations and integration, this is going to be effective positively and massively. Also HyperView, SimLab, Inspire, and all the other applications that will leverage this backend. Last but not the least, on the pure HyperMesh post activity, you're very much aware that we have been introducing in the previous releases, thanks to the work that led by Varun, the legend as an entity, so with all the customization and relevant entity editor-based workflow. Now we have been introducing the possibility to display any numeric result as a category legend, meaning that, for example, you can convert a stress plot into 4 levels based on a magnitude and assign a level set from low, medium, high, and critical, but give any type of string to that. That allows the definitions of any label and every value range through the workflows from the entity editor, and that this can be assigned to any contour plot, meaning that basically everyone can have his own level set, his own custom criteria, and this allows more flexibility in terms of how we can use the tool towards any specific type of use case. Obviously, we can also right-click on the legend and pick Make Category Legend option, and then use it. Now, moving still, if you wish, under the HyperMesh post umbrella. And again, my major thanks goes to Arnaud and the development team that has been working with on the free body workflows. For the users of HyperMesh post, you are now familiar with the concept of the plot control. And now this has been moved also to the free body workflow. We have been kind of clubbing some of the legacy tool into, let's see, a reduced number of entry point to make also the look and feel being more consistent. So now we have a create and edit of the free body section, and we have been introduced the possibility to create by means of a finite or an infinite cut plane. Also with the possibility to select intersected parts or components for the definition specific of which are the free body sections that will be affected. It can also go on a mesh based with enhanced workflow for the selections. So when you select elements, it's not going to allow you to pick any other nodes, but those that are, let's say, consisting the element that we have selected. Then we can create the free body plots as a plot controller with the possibility of showing forces and moments either by free body or resultant, adding the resolution in systems, and also clubbing the possibility to switch from the grid point forces to the displacement, translation, and rotations. Arnaud was very kind to prepare a couple of videos showing how we can create, for example, the several free body sections with the create and edit paradigm. So you go into these new icons, you can basically enter already the relative TOC browser for the free body selection, and you can create an infinite plane. And with the manipulator, you can drag the plane position across your model, identify also what is the realizations in terms of elements and nodes, or just by seeing what is the section cut that has been created. Also, as you can see here, you can select which are the parts which will be affected. You can switch from a finite plane also to an infinite plane to a finite plane. The workflow is the same when it comes to moving and manipulating the plane in the different position, but this gives also another beautiful capability of deciding the size of the section cut, which will be very beneficial to intersect the relevant, let's say, part of the sections that we want to cut. Obviously, everything is based on automation, so you can imagine how slicker the workflow can be also through the automation level. The plane can also be increased in terms of searching algorithm. We can also have the possibility of including or excluding the rigid. So what Arnaud was able to convey is to pack inside an entity base, or really object-oriented capabilities as member functions, to have all the tools that are available to support the different nuances that our customers, either from aerospace or from marine, railways, and others, are required for the generations of the section cut and the relevant free body. Obviously, there is still the possibility to import the sections out of a CSV, import and export them. This can be done, for example, directly from the free body sections browser, and identify what are the parts that are, let's say, affected by the generation. This part is also showing how create mesh-based sections, which is namely, let's say, the standard one that we were used to do. So you can have an explicit definition, you can pick elements, for example, and then automatically you can identify what are the boundary nodes that have been, let's say, affected. And then by clicking new other elements, you can define, you can see how this is automatically updated. Through micro dialogues, you can define as well the locations of the summation point or the system which has been, let's say, used for the extractions of the data. Obviously, this is possible either from a workflow, so from the context, but also through the entity editor. And basically, you can switch from a context-based workflow to a full, let's say, browser-driven workflow as such, right? And with all the other possibilities, we have been adding tooltip and the possibility to see in the TOC browser what are the type of sections. For example, the infinite cut can also be realized from the plane definition into a mesh definition, right? So full flexibility on the control of the free body section generation. Obviously, the free body section generation is a part which is as well independent from the presence of the results. And now in this last video that I'm going to share is the possibility to plot the free body forces. So as I was mentioning, we have been introducing a new free body control, which follows the same paradigm of the contour vector, tensor deformations, and marker. So these have been created. You have the possibility to showcase them in the browser, to activate and deactivate them on demand. And by editing or modifying the attributes of the several, let's say, free body sections which have been selected for the plotting, you will be able to see a live update if the plot control is shown on how the things will be changing. This is the same also when you switch to the subcases. And obviously, this can be overlaid with a contour or with a tensor or with a deformation. In this case, as you can see, you can move the plane generations of a free body section, and you can see that the update is live. I'm anticipating eventually a question. This update is live. So far, we do support the generations of these sections. Even if it's a plane, the plane is nothing but a detector of the locations of elements and nodes, which are, let's say, the FE-based section cut, if you wish. But we are working, and this is heavily on our roadmap to have the possibility of interpolate the forces and moments throughout the elements that we are cutting, as requested by many of our customers, right? So I hope you see where we are reading. Now we have been introducing the right infrastructures for the plane generations and the display. Next phase is to improve the other tools like the trace plot, panel plot, and bar plot that you see there, and introduce the arbitrary section cut, if you wish. Okay. So want to skip a little bit. I want to mention we still support the generations of free body table, fields, and the potato plotter as we had in the former workflow. Now there is just a satellite icon under the plot, and this will be invoking what we have been naming the free body manager, where every user can select the several sections, the load cases, and then decide to create tables or to extract fields, and then out of those tables, for example, creating the free body plot and the free body diagrams in HyperGraph. Want to mention as well that this is in the pipeline to have a leverage all the other plotting capabilities inside the, let's say, our plotting module that Sandesh is leading. What we are showing here, we are still, as I mentioned, everything can be accessed by the several entities, and that's the same also for the resolutions of the output system. So we can solve in the basic systems, we can solve in analysis system of the nodes, but we can also solve on the user-defined system. So everything is available, as I mentioned, both on the context, but namely from the entity itself. And by stressing the support of the entity-based workflow, I'm stressing how much you have automation basically on the fly. And this is, if you wish, the paradigm that we are trying to use as much as possible within the HyperMesh infrastructures to have a strong entity-based footprint for our development, so that we can enhance and that we can leverage out of the box, capabilities of HyperMesh towards the automations, being this either in TCL or in the next future in Python. And with that, I'm handing over to Varun, who is going to discuss and showcase to you the update on the HyperView and HyperGraph site. And thanks everyone for your attention.
Thank you. So for HyperView, I will start by highlighting some important updates we have done for Abacus ODB post-processing. So the first one I want to bring to your attention is a new reader option, which will boost ODB performance. This basically groups all the elements under an assembly into a single component. And in our internal tests, we see a significant improvement in the performance with this reader option enabled to true. We have also done a few other performance improvements when it comes to handling very large ODB files. And as you can clearly see in this chart that I'm showing here, we have done several tests on different ODB files coming from different customers. They cover a variety of scenarios, and you can see in all these cases we do see a significant boost in the loading speed for ODBs. So this is a very major update that we have made. We have done several internal benchmarks to see the improvement across a wide variety of use cases. We are also currently testing some of these files on a customer setup. I cannot share the data here, but there also our initial tests show significant improvements. So something obviously our customers can benefit from. And since this is done to the ODB reader, which is a common component, you can expect a similar boost in performance when you load these files in other applications such as HyperMesh Post. Also, another regular update that we do in each release, we are now supporting Abacus ODB 2023 version in this release. So something to be aware of. We get frequent queries from customers about the support of this version. So please note this update as well. Next, I want to highlight a few other important HyperView enhancements. I will start off with a small but very useful feature requested by several customers. This is a feature called Synchronize ISO Plot with Contour. As you can see on the screen, it's an option that's available on the Legend right-click menu. It basically keeps the ISO plot always in sync with the contour plot. So whenever you create a contour plot, automatically an ISO plot is also created. And the Legend will show a small slider at the bottom, which you can move up and down to control the ISO display. And if you happen to change the contour plot to a different data type or to a different setting, the ISO will automatically follow that change. So this is a mode basically that keeps the ISO always in sync with the contour. If you do not wish to have this mode on, you can obviously turn it off. And if you like this feature to be on all the time, there is a preference statement that you can set in the preferences file, and that will basically keep this mode on as soon as you launch the session. Next is a name change announcement here. As Michele mentioned earlier, we have been going through a rebranding exercise in 2023 for all the simulation products. So in keeping with that, the HyperView upfront loader profile that some of you may be aware of is now renamed HyperView Multi-Core. So this change will reflect anywhere in the product and in the documentation and in the training material. So for those of you who are not aware of, HyperView Multi-Core is this newer, faster version of HyperView that we have been developing and heavily focusing on. I can give more details on this profile, on our vision and plan for this in the later half of the presentation, maybe in the Q&A section. But for now, please note this name change. Then a few other enhancements I'll mention here. HyperView does support a reverse zoom now. As you may know, HyperMesh already supported this option. And since both the products exist in the same framework, we have now made sure that HyperView can also support a reverse zoom. This option is available under Preferences, Common section. Few other changes here to mention. The auto hide capability on nodes has been improved. We are now better covering cases where the note is attached to a zero length element, say a mass element, and the auto hide feature has been improved to work for these situations. Then coming to extract data tool, which is the tool that does data extraction from solid elements as well as stress linearization calculations. This tool has been improved, especially when it comes to tolerance and error handling. So there are scenarios where you can have a point lying on the surface, but the code will not calculate properly for it. So in such cases, you can increase the tolerance. We post an error message and we allow you to increase the tolerance so that the values can be extracted for that particular point. So this has been taken care of in this release. Then coming to HyperGraph, the major highlight in the release is the faster build plots dialog. As you can see here, this reduces our time to list all the requests from over 30 minutes to just a few seconds for more than 1 million requests. And another important benefit here is that previously we were not showing the requests when it was more than 10,000, and you had to use the search filter to find the requests. But now with this update, we will be showing all the requests in the dialog itself. So you can directly find them here, or you can use the search filter. We have also added multi-subcase support in the seam reader. I think this was also requested by several customers. And with that, I conclude my presentation. So just to recap, I will summarize the changes that we have been making in 2023 across all the post products. So obviously, as Michele mentioned, our major focus and efforts on this release was to support the migration to this single process architecture. But beyond that, we have worked on improving the GUI responsiveness and database loading speeds. On the HM post side, we have covered relative path, custom category legend, and improved overall memory management for result queries. There is also an enhanced free body workflow that we have covered. And on the HyperView and HyperGraph side, we have a huge performance improvement in ODB loading times. We have a renaming of HV upfront loader to HV multi-core, and we have a faster build plots dialog in HyperGraph. With that, I conclude my presentation part. Thank you all.